example 2 of your journal from yesterday. So, example 2. Jason jumped off a cliff into the ocean in an acapello while vacationing with some friends. His height as a function of time can be modeled by the function h equals negative 16t plus 16t plus 480. While t is the time in seconds and h is the height in feet. All right, so if you guys have ever been to a pool or swimming, all right, it may seem like it's just a straight drop down, so it doesn't have like a maximum height or anything, or the height's the y-intercept, but that's not necessarily true. Because if you are jumping off a cliff, all right, don't you have to get a little bit of air before you actually start falling? So if we were to sketch this picture, let's say the cliff edge was here, Jason's like here, and he jumped up a little bit and then went down. All right. So, what is the height of the cliff? So, without even having to graph it, what's the height of the cliff? 480. How do you know that? Right. So, remember, the constant of any standard form quadratic gives you your y-intercept, which is also your initial height. So the cliff itself is actually 480 feet high. All right. Now, I'm going to give you guys about 5 minutes. Take a second, graph the function in Desmos, and answer questions B through D. All right, using what we learned yesterday. So take a second, graph it in Desmos, answer questions B through D. And be very careful when you're plotting it in Desmos. Make sure that it's in there exactly as you see it. So all you're doing is graphing it in Desmos, answering those other 3 questions, B through D. Nothing new from what we learned yesterday. You guys might have to zoom out like a lot to see the very top of it. you squared 16. So it was doing like 256 to the T power. One more minute. Quick. All right, thumbs up if you're ready. All right, most of you guys. So let's go with Riley E. What'd you get for how long it took to reach the maximum height? Good. And how'd you know that? So how'd you get the 0.5? Right. So it's the x value of the vertex. So this vertex right here, the x value is 0.5. All right. So James, what did you get for the actual highest point that you reached? Good. How'd you get that? Right. It's the y value of the vertex. Good. So 484 what? That's 484. All right. Last one. Jason hit the water after how many seconds? Addie. Okay. Ben, help her out. Did you get letter B? Okay. Did you get letter D? 6 seconds. And how'd you know that? Right. It's the positive x-intercept. So that's when it hits the ground. So this point right here was 6, 0. All right. So again, these aren't necessarily hard. You just got to know which key feature goes with what contextual part. And that's exactly what I got when I did it myself. All right. Last one, and then we're done. I'll give you guys some work time. So look at example 3. So we'll just model this first, and then I'll have you guys find the answers to it. So model rocket launched from a roof of a building. The flight path is modeled by this function. H is the height of the rocket above the ground in meters, and T is the time in seconds. So first off, if I was to sketch this picture, what is the rocket's initial height? 10 what? Feet. Because we get that right here. So this is the initial height. So the building that was launched off of was probably 10 feet tall. All right. So let's say that this is the building about right here. This is 10 feet. And we launched the rocket. This will look like a terrible rocket, but you know what? It's fine. All right. Its trajectory looks something like this. And then it hits the ground. So take a couple of seconds, or minutes, I should say, and find B through D. So similar things to what we've already done. So remember, main key features you're looking for: vertex, x-intercept. That's pretty much it for those three questions. You just got to know which part of which key feature to use for what context. Also, if you get a decimal round to say 2 decimal places. Ready. All right, Olivia, what did you get for the rocket's maximum height? Say that again. Did everyone else get 15? Check your graph. So Michael, help her out. What'd you get?
No.
What'd you get? Okay.
I think I definitely got it wrong. I don't think that's right at all.
I got 55. Did anyone else get 55?
Yeah.
Okay. So, yeah, I was about to say, just check your graphs because I think he just put it in wrong. All right. So I got h is equal to 55 feet. Yeah, so that's why I said, guys, you gotta be very careful when you put things in. So why did I get 55? It comes from where? The vertex. What part of the vertex? Your y value. So the y value of the vertex is 55. All right. Who's got how many seconds to reach the maximum? It was 3 seconds. Good. And that would be the x value of vertex. And then who has how long it takes before it hits the ground? 2 decimal places, so I want to round it to. Right. So you hit the ground, took about 6.32 seconds. And that came from our x-intercept, which was 6.320. Or it was like 6.31 and a bunch of extra numbers. I rounded it. All right. Any questions on any of these problems? All right. So again, the biggest room for error here with these problems is you just got to make sure you type it in correctly in decimals. So before you even start answering questions, just double check what you typed in and compare it to the actual function you were given. All right. Make sure that you know the squares are where they're supposed to be. That you put the correct variable where it's supposed to be. Because the tiniest little error in what you type in can completely change your answer. All right. So this is one of those where like it's not so much a calculation error, it's more so a user error for putting things in the calculator. So make sure you double check what you put in the calculator. All right. Okay. So for the rest of class, you got over an hour for this. All right. So for the rest of class, I'll give you your 5-minute break after I explain instructions, and then we'll come back and just do work. All right. So your work for today is you should be able to finish your 8.5 Delta Math. If you've already finished it, because I saw that some of you already did, there's an 8.5 digital escape room. It's exactly the same as what we've been doing. All right. So it's not very hard, shouldn't take you very long. That link is already posted in the assignment page on Canvas. After you finish that, work on packet work, work on makeup work. So the escape room is a grade, so make sure you do it. All right. So I'll give you guys your 5-minute break, and then you'll come back and work. All right. And you can do the work in Starbucks mode as well, just no phones. The escape room? No, I have it set for Monday. That's fine. As long as you're actually working.